Third one is alkynes. Grignard reagent reacts with determined alkynes following the alkenyl Grignard reagents, which upon treatment with alkyl halides to give the higher alkynes. Fourth one is primary alcohols. By action with the ethylene oxide followed by the hydrolysis, Grignard reagents reacts with the ethylene oxides to form the addition products, which on hydrolysis with dilute hydrochloric acids form the primary alcohols containing two carbon atoms more than one alkyl halide. For example, ethyl magnesium bromide when reacts with the ethylene oxide forming the addition product, which upon hydrolysis give the 1-butanol. Fifth one is the secondary alcohols. By action with the alkyls other than formaldehyde followed by the acidic hydrolysis will give the secondary alcohols. For example, the acetaldehyde react with the benzene magnesium bromide ArMgBx, that is a Grignard reagent, will form upon hydrolysis the 1-methyl ethanol. By treating an excess of Grignard reagent with the ethylene formate, can reacts with ethyl formate to form aldehyde, which in turn reacts with the other molecule of the Grignard reagent to yield a adduct, which forms a secondary alcohol upon the hydrolysis. Tertiary alcohols. By action with the ketones followed by the hydrolysis, the ketone will form the tertiary alcohol. A tertiary alcohol having at least two similar alkyl groups may be prepared by the interaction between an ester other than the formic ester and the excess of a Grignard reagent of 2 moles. The reaction proceeds in the 2 steps. By reaction with the acid chlorides and anhydrides, Grignard reagents with 2 moles react with the acidic chlorides or anhydrides to give the addition products, which upon the acidic hydrolysis give the tertiary alcohols. The reaction takes place in the 2 stages. Ethers. Grignard reagents can react with halogenated ethers to yield the higher ethers. Aldehyde. When a Grignard reagent is treated with the ethyl formate, an aldehyde is formed. However, with the excess of the Grignard reagent, the product obtained is a secondary alcohol. Ketones. By treatment with the alkyl cyanides followed by the acidic hydrolysis. For example, acetonitrile on reaction with the ethane magnesium bromide, that is reagent, will give the hydrolysis 2-butanone. Monocarboxylic acids. Grignard reagents interact with the dry ice, that is solid carbon dioxide, to form the addition products, which upon acidic hydrolysis will give the monocarboxylic acids. Thioalcohols. Grignard reagent can react with the sulfur to give an addition products, which give a thiols on the hydrolysis. Phenols. Aryl magnesium halides reacts with oxygen to form the addition products, which upon the hydrolysis give the phenols. Alkyl cyanides. By the interaction of the Grignard reagent 1 mole and a cyanogen chloride or cyanogen, the alkyl cyanides are formed. Excess of Grignard reagent is avoided since it will react further to form the ketones. Primary amines. Grignard reagent with chloramine to form the primary amines. Reaction is alkyl magnesium chloride react with orthomethyl hydroxyl amine to give the 1-degree amine. Sulfonilic acids. On passing the sulfur dioxide into a well-cooled solution of Grignard reagent, an addition product is formed, which upon hydrolysis will give the sulfonilic acid. Diethic acids. These are prepared by the action of Grignard reagent with carbon disulfide followed by hydrolysis. Organometallic compounds. Grignard reagents and inorganic halides interact with each other, resulting in the formation of other organometallic compounds. Abnormal addition of the Grignard reagents. Addition to the hindered ketones. If the Grignard reagent for or the ketones contains and branching at the alpha carbon, sometimes the usual addition reaction does not occur to the steric endurance. Instead, reduction occurs in which a hydride ion is transferred from the Grignard reagent to the ketone via a six-membered cyclic transition state in a manner similar to the Merwin-Ponder-Worley MPV reduction. Organozinc compounds. Methods of formation. From the alkyl halides, alkyl iodides can react with the zinc copper couple in a high boiling point to form the alkyl zinc iodides, which upon subsequent distillation in an atmosphere of carbon dioxide undergoes the disproportionate reactions to form the di-alkyl zinc compound. From the organoaluminium compounds. Treatment of trialkyl aluminium with zinc chloride give the dialkyl zinc compounds. This method forms the basis of laboratory preparation of these compounds. Physical properties. Dialkyl zinc have the linear geometry to the sp hybridization of zinc atom. They are non-polar, lower boiling liquids or lower melting solids soluble in the organic solvents. The lower zinc compounds are highly inflammable in air and hence are usually prepared and used under the CO2 atmosphere. Chemical reaction. Reaction in water to forming the alkenes. With the alkyl halides, they will form the alkanes containing the quaternary carbon atom. Reaction with the acidic chlorides. They react readily with the acidic chloride to form the ketones. That is, we have taken example diethyl zinc with the acetyl chloride forms the butanone. Reformatsky reaction. When a aldehyde or a ketone is added to the solution of the alpha haloester in the presence of zinc, an organozinc compound is first formed, which then adds to the carbonyl group in the manner similar to the Grignard agent reagent to form the beta hydroxy ester. This reaction is called Reformatsky reaction and is useful for preparing the beta hydroxy esters and their derivatives. Iodomethylene zinc oxide. Iodomethylene zinc oxide iodide is an important organozinc compound and is obtained by the formation action of the zinc copper couple on methyl iodide. It reacts with olefins to form the cyclopropane derivatives. This reaction is known as Simon-Smith reaction. Organolithium compounds. Compounds in which the lithium atom is directly bonded to a carbon atom are called the organolithium compounds. For example, methyl lithium, ethyl lithium, and butyl lithium and phenyl lithium. Formation of alkyl lithium. By reaction of alkyl halide with lithium. Alkyl lithiums are generally prepared by treating an alkyl halide with lithium in hexane, benzene, or any under hydrocarbon solvent at a very low temperature in an inert atmosphere of nitrogen gas or the argon. By metal exchange. Alkyl lithium can be readily prepared by the replacement of the one metal by another. Chemical reaction of alkyl lithium. Resemblance with the Grignard reagent. Formation of hydrocarbons. Like Grignard reagent, they react with the compounds containing active hydrogen to form the corresponding hydrocarbons. Formation of the primary, secondary, and tertiary alcohols. Primary alcohols are formed by the reaction with the formaldehyde. Secondary alcohols are formed with the action of aldehyde by action with aldehydes other than formaldehyde. Tertiary alcohols are formed by the action with the ketones. Formation of ethers is done with a reaction of the compound with the monochloroether. Formation of aldehyde occurs by the reaction of the compound with the ethyl orthoformate or the hydrogen cyanide. Formation of ketones is done by the action with any orthoester other than orthoformic ester or alkyl cyanide. For example, we have taken the ethyl orthoacetate in the reaction in the presence of benzene will give the acetone. All other reactions are similar as that of the Grignard reagent. Difference from the Grignard reagent. Organolithium compound being more reactive than the Grignard reagents undergo some additional reaction discussed as below. Action with the carbon dioxide. Grignard reagent yields the carboxylic acid with carbon dioxide while organolithium compound yield ketones. Action with carboxylic acid. Alkyl lithium compounds react with the carboxylic acid yield the ketones as the main product. Grignard reagent on the other hand will give the alkanes. Reaction with alpha, beta unsaturated carbonyl compounds. Organolithium compounds being more nucleophilic predominantly undergo 1, 2 addition to the alpha beta unsaturated carbonyl compounds, whereas the Grignard reagent give only the 1, 4 addition products. For example, we have taken the benzyl ketone in the presence of hexane will give the 1, 2 addition product, which on the last will give the product named 4-phenyl penta 2-one.